Okay, we know the mechanism for Clainsen reaction. So generally speaking, if you have an ester reacting with another ester, okay, so let me call this other ester. Let me put this other ester in blue, but I will intentionally show the alpha carbon. So the alpha carbon of this ester, assuming they're similar, I'm just showing the alpha carbon. Okay, the alpha carbon of this ester will be used to make a carbanion. That is, if you add a strong base, let's say like ETO minus, that ETO minus takes a hydrogen off the carbon bonded to the carbonyl, that's called the alpha carbon. You get a carbanion. Now, this carbanion is going to be used as a nucleophile to attack the carbonyl of the second molecule, and the R group falls off. This is a very summarized mechanism. So when OET takes out the hydrogen, you get an alcohol. Okay, so in Clainsen condensation, you'll always lose an alcohol, and you click two molecules together. So out of the attack of the alpha carbon to the carbonyl, and as this falls off, this is what you end up with. There's gonna be a connection, okay, from the alpha carbon. So let's say this is where they were connected, assuming that this arrow was red. It's gonna give you the red bond right here. Okay, that's a single bond joined onto the carbonyl, which now still has the R group. The OET fell off. How did it fall off? It fell off as ethanol. Okay, once the hydrogen was taken out, once this hydrogen was taken out by the base, you get ethanol. And as this leaves, okay, when you do this attack and this leaves, it gives you ETO minus, but that ETO minus is quenched by a second step to give you ethanol. So you still get ethanol here, you still get ethanol there. So that's why I said OET will leave us ethanol. So that's the shortcut. Now let us do some examples based on what I just shown here. Okay, so this does not always have to be ethanol. This could be an R group. Okay, so let's say you have this ester. You are reacting it with itself. Okay, I know this should fall off by shortcut, and I know we need to use the alpha carbon, so we need to react with itself. So I need to make sure the structure is the same. So this ester is the same as this. You're reacting two molecules of esters which happen to be similar. So this will offer its hydrogen, and the OET should fall off. So the shortcut is to lose ethanol, right? Ethanol will be the byproduct. This is CH2CH3 that makes ET. CH2CH3 is ethyl, so you get ethanol. It's just this molecule. Okay, that's ethanol. When this piece falls off, you get ethanol. Okay, and then you join this alpha carbon to the carbonyl. Okay, so the carbonyl will be down here. It still has its R group, and we're gonna join it. We're going to join it onto the alpha carbon of this ester. So we still have those two methyl groups. That's a CH3, that's a CH3. I'm not showing the mechanism, this is just survival technique in class, in the test. So that will be a product. This will be organic product from Clainsen reaction. Alright. Shortcut. So now let me do more examples. So let's say you're given this molecule. As given in the notes, and reacting it with itself. So remember, one of the molecules should give you the nucleophile. So you have an alpha hydrogen here. I can use one of the alpha hydrogens to make a carbanion. You know, if you add a base, for example OAT minus, like I said, we'll take that out and create a lone pair. I'm choosing OAT because I know I have an ethyl ester. If this was methyl ester, I'll use OMe minus. So you get your carbanion. Now I will not move with the mechanism forward because I just wanted to show you the carbanion. This carbon, alpha carbon, be used to attack the carbonyl, and this falls off. But as per our shortcut, I just know that these two must fall off to give me ethanol. Okay, following our shortcut, I'll get ethanol, and then the rest should connect. So I know the one in blue now has only 3 carbons, those 3 carbons, and the 3 carbons are joined onto the alpha carbon of the nucleophile from this ester. So that's my alpha carbon. Okay, this used to be my alpha carbon. I still have 1 hydrogen. I only lost one survived. So this will be our product. So whichever way you draw it, so long as you have the right structures there, you should be fine. Okay, one more, employing our shortcut. So now what if we are given this molecule reacting with itself? I'll show you the shortcut again. Reacting with itself in a Clainsen condensation. So I know I have 3 alpha hydrogens. So I have to pull out one to make the carbanion. So let's assume that has to go, and still when you attack this carbonyl, this will fall off. Just like we did here, we attacked the carbonyl, that this group fell off. So same thing, if we attack the carbonyl here, this will fall off. So I'm gonna circle it. So my byproduct should be methanol or CH3. There's a CH3 here, it's just not written. And then I click the rest of the structure. Okay, so I'll click the rest of the structure. Like that. This time this will be our product, our keto is called beta keto ester, because this is the alpha carbon, that's the beta carbon, the ketone is on the beta carbon, and that's your Clainsen product. So at least you now have a feel on how to predict products. So if I ask you what is the product when these two guys react, if the base is OCH3 again because I have an ethyl ester, what is the product? This is the answer I'll be looking for. So here probably I'll ask, what is the product when two equivalents of these react in presence of a strong base? What's the product? This is the product I'll be looking for. Okay, I just thought I should talk about that so you'll be clear with it.